In the quiet back rooms of 19th-century pharmacies, sitting on dusty shelves next to tinctures and tonics, was a strange, clear liquid. It was sold not as a fuel, but as a solvent, a cleaning agent, and even a supposed treatment for head lice. This volatile substance, known then as gasoline or petroleum ether, was little more than a curiosity. Nobody could have imagined that this humble, flammable liquid would soon ignite a revolution, redraw the map of the world, and define an entire century. This is the story of gasoline. To understand gasoline, we first have to travel deep underground to the ancient remains of marine organisms compressed over millions of years into a thick, black goo, crude oil. For most of human history, this crude oil was a nuisance or a minor resource used for waterproofing boats or in lamps. But in the mid-1800s, scientists discovered how to refine it, specifically through a process called fractional distillation. By heating the crude oil, they could separate it into different components, or fractions, based on their boiling points. The most valuable product was kerosene, a cheap, effective replacement for whale oil that brought bright, steady light into homes across the globe. Kerosene made men like John D. Rockefeller titans of industry, but the process created a massive problem. For every barrel of valuable kerosene, refiners produced a barrel of a much lighter, highly flammable, and seemingly useless byproduct. This was gasoline. It was so volatile, it was considered a fire hazard. Refiners couldn't sell it, so they often just dumped it into rivers at night, a dangerous and polluting secret of the new oil economy. Gasoline was waste. But in a workshop in Germany, an invention was taking shape that would turn this waste product into black gold. An engineer named Karl Benz was perfecting a new type of engine, one that used internal combustion. Instead of steam, it created power through a series of small, controlled explosions inside a cylinder. The fuel for these explosions, a light petroleum spirit, in 1886, he patented his motor wagon, the world's first true automobile. It was a fragile, three-wheeled contraption, but it held the seed of the future. Yet, the world barely noticed. The idea of personal self-propelled transport seemed like a fantasy. It took the vision and courage of Karl's wife, Bertha Benz, to show the world what was possible. In August 1888, without telling her husband, she took their 2 teenage sons and set off in the motor wagon to visit her mother, a journey of over 60 miles. It was the world's first long-distance road trip. There were no gas stations, no repair shops. When she needed fuel, she had to stop at a pharmacy in the town of Wislec and buy Le Gruen, another name for the same petroleum solvent. She used her hatpin to clean a blocked fuel line and her garter to insulate a wire. Bertha's journey was a masterstroke of public relations. It proved the automobile was not just a novelty. It was a practical, if challenging, means of transport. Suddenly, the useless byproduct of kerosene refining had a purpose. The nascent automobile industry needed gasoline, and the oil industry was more than happy to provide it. But this early gasoline was a crude affair. It was inconsistent, dirty, and varied wildly from one producer to another. There was no standard. This created a huge problem for early engines, a destructive rattling and pinging sound known as knocking. Knocking happened when the fuel-air mixture in the cylinder ignited unevenly, creating shock waves that robbed the engine of power and could eventually destroy it. To build more powerful and efficient engines, automakers needed a better fuel. The challenge fell to a brilliant research team at General Motors, led by the inventor Charles Kettering. In the 1910s, he assigned a young researcher, Thomas Midgley Jr., to a single crucial task: find a chemical additive that could eliminate engine knock. Midgley's team embarked on a long, frustrating search, testing thousands of compounds. They tried iodine, which worked but smelled awful. They tried ethanol, which also worked but was seen as competition by the oil industry. Then, in 1921, they found their miracle solution, a compound called tetrethyl lead. When added to gasoline in tiny amounts, it dramatically smoothed out combustion, silencing the knock and allowing for the design of high-compression, high-power engines. General Motors and Standard Oil formed a joint venture, the Ethyl Corporation, to produce and market leaded gasoline. It was hailed as a technological marvel. The era of the powerful automobile had begun. Cars became faster, heavier, and more accessible. Cities began to sprawl outwards, suburbs were born, and the paved road became the artery of modern life. The world was being reshaped, molecule by molecule, by leaded gasoline. But this triumph had a dark, hidden cost. Lead is a potent neurotoxin. From the very beginning, workers at the production plants suffered horrific consequences, including hallucinations, insanity, and death. The press dubbed the chemical loony gas. Despite the clear dangers, the industry, led by Midgley, mounted a massive public relations campaign to reassure the public that leaded gasoline was perfectly safe. For decades, they were tragically successful. While the industry promoted its leaded fuel, it also needed a way to measure and market its antinocke properties. This led to the creation of the octane rating system in 1927. The system compares a fuel's P performance to two reference chemicals: isooctane, which resists knocking and was given a rating of 100, and heptane, which knocks easily and was rated 0. A gasoline with an octane rating of 87 performs like a mixture of 87% isooctane and 13% heptane. This simple number became a powerful marketing tool, with high-test or high-octane gasoline promising more power and performance. For nearly 50 years, the world ran on lead. Billions of tons of microscopic lead particles were pumped from exhaust pipes into the atmosphere, settling in the soil, water, and our bodies. The full, devastating scale of this environmental poisoning would not be understood until the work of one tenacious scientist, geochemist Claire Patterson. In the 1950s, Patterson was trying to determine the age of the Earth by measuring lead isotopes in ancient rocks and meteorites. But he kept running into a problem. All of his samples were massively contaminated with modern atmospheric lead. His lab became a sterile, clean room as he tried to escape this invisible pollutant. Through his meticulous work, Patterson proved that lead levels in the environment and in human bodies were hundreds of times higher than their natural prehistoric levels. He identified the source: tetraethol lead in gasoline. Patterson became a fierce, lonely advocate against the powerful oil and chemical industries. He faced ridicule, had his funding cut, and was barred from conferences. But the scientific evidence was undeniable. His work, combined with growing environmental awareness and the need for new catalytic converters that were poisoned by lead, finally forced a change. Starting in the 1970s, countries around the world began the slow, difficult process of phasing out leaded gasoline. It was one of the great public health victories of the 20th century. The transition to unleaded fuel marked another evolution for gasoline. Without lead, refineries had to find new ways to boost octane. They turned to more sophisticated refining processes and new oxygenate additives like MTBE and later ethanol. Modern gasoline is no longer a simple distillate, it's a complex chemical cocktail, a precisely engineered formula. It contains detergents to keep fuel injectors clean, corrosion inhibitors to protect the engine, anti-icing agents, and antioxidants. Each brand has its own proprietary blend, all designed to meet strict performance and environmental standards. From a dangerous waste product to the lifeblood of modern society, the journey of gasoline is a story of incredible ingenuity and unintended consequences. It gave us personal freedom, connected our world, and fueled unprecedented economic growth. It allowed us to build vast cities and explore the continent on ribbons of asphalt. But it also came at a steep price, written in the air we breathe and the climate we are now struggling to stabilize. The story of this remarkable liquid is far from over. As we stand at the dawn of a new energy era, with electric vehicles and alternative fuels on the horizon, the dominance of gasoline is finally being challenged. But its legacy is all around us. It's in the design of our cities, the hum of the highways, and the very rhythm of modern life. It's a powerful reminder of how a single substance, once worthless, can change everything. Thanks for joining us on this journey through the history of things. If you enjoyed this story, please give this video a like and consider subscribing to our channel for more deep dives into the objects that have shaped our world. We'll see you in the next one.